Teacher Joshua, your mathematics learning guide here at DepEd TV. This is the last chapter of our first quarter journey. We will apply our knowledge and skills we acquired in the last few lessons about the rectangular coordinate system and linear equations. And we will make it double the fun. So buckle up, get your self-learning module, pen, papers, and ready yourselves for the challenge ahead as we learn systems of linear equations in two variables. Do you make it a habit to save money? Do you have your own piggy banks or alcansya at home? The simplest way to save money is to collect your change or coins and keep them in a coin bank or your alcansya. Start with an easy and achievable goal. Then gradually increase your targets as you adjust your daily or weekly budget. Also, make sure that you will not spend them unless it is needed or for emergencies. So, let us say that you start saving 1 peso and 5 peso coins in your alcansya. You know that you have 10 coins with a total amount of 22 pesos. Now, let us use what we learned to create a mathematical model to represent your savings. To write a mathematical model in which we do not know the number of each coin yet, we can use variables x and y. Let x be the number of 1 peso coins and y be the number of 5 peso coins in your alcansya. Since there are 10 coins in total, we can say that x plus y equals 10. But how can we write the second statement? The total value of the 1 peso coins can be represented by 1 times the number of coins, x, while the total value of all 5 peso coins can be written as 5 times the number of coins, y, and their sum is 22 pesos. Hence, the second equation is 1x, or just x, plus 5y equals 22. Again, the mathematical model for our savings is given by two equations, x plus y equals 10 and x plus 5y equals 22. A set of two or more linear equations in two variables is called a system of linear equations. Remember that a linear equation is an equation whose degree is 1. So in our previous mathematical model, do you have an idea how many 1 peso and 5 peso coins do we have if there are only 10 coins and a total amount of 22 pesos? We can answer this by making a table of values. We know that there are 10 coins and the total amount is 22 pesos. So we can say that if there is 1 peso coin, there must be 9 5 peso coins. But how much do you have with this? It is 46 pesos, which is not equal to the actual 22 pesos. Now, let us think of another number. Let us say there are 4 1 peso coins. How many 5 peso coins do we need to have 10 coins? We need 6 5 peso coins. Now, how much is this? You have 34 pesos. But this is still way off our actual savings. Can you think of another set of numbers? Let us try 7 1 peso coins and 3 5 peso coins. There are 10 coins indeed. Now, how much is this? Finally, we have 22 pesos. Again, we started with 7 1 peso coins and 3 5 peso coins in our alcansya. The previous problem illustrates that an ordered pair xy is a solution to a system of linear equations if it satisfies all equations in the system.
For example, the ordered pair 7, 3 is a solution of the system that represents our coin problem.
Now, try this. Given a system, with x minus 3y equals 2 and y equals 2x plus 1, identify if the following points are solutions or not. Let us start with 0, 0. To check if this is a solution or not, we just substitute the values of x and y to the equations and identify if it is true or false. We have x minus 3y equals 2. After substitution, we will have 0 minus 3 times 0 equals 2. Can you simplify the left side of the equation? 0 minus 3 times 0 is just 0. Now, is 0 equal to 2? No, it is not. Hence, this statement is false. It means that 0, 0 is not a solution to the system. Try this. Is negative 4, negative 2 a solution to the same system? Substituting to the first equation, we have negative 4 minus 3 times negative 2 equals 2. Now, is the statement true or false? Indeed, negative 4 plus 6 is equal to positive 2. But note that for an ordered pair to be a solution, it must satisfy the other equation as well. So substituting negative 4, negative 2 to y equals 2x plus 1, we will have the mathematical statement negative 2 equals negative 8 plus 1. Then the right side of the equation, when simplified, will be negative 7. It is evident that this mathematical statement is false. So it means that negative 4, negative 2 is not a solution. Let us see if this last point, negative 1, is a solution. Again, substituting to the first equation, we will have negative 1 minus 3 times negative 1 equals 2. This can further be simplified as negative 1 plus 3, which is equal to 2. Hence, the statement is true. Next, we substitute the coordinates in the second equation. We will have negative 1 equals 2 times negative 1 plus 1. Is this true or false? The mathematical statement is true since negative 1 is equal to negative 2 plus 1. Therefore, negative 1 is a solution to the system of linear equations. Furthermore, a system with at least one solution is called consistent. And an inconsistent system means there are no solutions or points that satisfy the equations in the system. There are also instances that the system of linear equations has an infinite number of solutions because its equations are basically the same. Given a system of linear equations ax plus by equals c and dx plus ey equals f, we can identify the type of system and the number of solutions by taking note of the coefficients and constants in the equation. If a over d is not equal to b over e, then the system is said to be consistent and independent since there is exactly one solution. If the ratios a over d, b over e, and c over f are all equal, then the system is consistent and dependent, meaning it has infinitely many solutions. Lastly, a system is inconsistent if the ratios between the coefficients are equal but not the constants. A over d equal to B over E, but not equal to C over F. It means that the system has no solutions at all. For example, identify what type of system is this and the number of solutions it has. In this system, we are fortunate that the given is already in standard form. So we just get the ratio between the coefficients. A over D is 1 over 3 or 1/3. Next, B over E is -2 over +1 or -2. Are they equal? Definitely not. Therefore, the system is consistent and independent, and it has exactly one solution. How about this one? Y equals 2/3 x minus 2, and y equals -x plus 1. Before we get the ratio between the coefficients, we must write the equations in standard form first. I hope you still remember how. We can use the addition property of equality in both equations, which will lead us to -2/3 x plus y equals -2, and x plus y equals 1. We can further transform the first equation so we do not have fractional coefficients. So multiplying both sides by -3, this can be 2x minus 3y equals 6. Now, what type of system is this? Upon inspection, A over D is 2 over 1, and B over E is -3 over 1. They are not equal. Hence, we have a consistent and independent system, and it has exactly one solution. During tests or exams, there is only one question, either the type of system or the number of solutions. So you just need to associate the conditions for each system of linear equations. Now, how many solutions does the system 2x minus 4y equals 5 and -3x plus 6y equals 10 have? The equations are in standard form, so we can proceed in getting the ratios. A over D is 2 over -3 or -2/3. How about the next ratio? B over E. B over E is -4 over 6, which in lowest term is also -2/3. Now, can we tell what type of system this is? Not yet, since there are still two cases with the first two ratios equal. So we check the ratio between the constants, C over F. What is it? It is 5 over 10, or 1/2. So, we have -2/3 equals -2/3, but not equal to 1/2. Therefore, the system has no solutions since it is inconsistent. Last example. How many solutions does the system 3x plus y equals -2 and 12x plus 4y equals -8 have? What is A over D? A over D is 3 over 12, which in lowest term is 1/4. How about B over E? It is 1/4 also. Now check the last ratio. -2 over -8, which in lowest term is also 1/4. So what can we conclude? The given system has infinitely many solutions. And that's it for today. You now have an idea about the system of linear equations and learned about one of its applications in saving money. I hope that you use the concepts we had today in your future budget plans. Now let's take a recap about this topic. A system of linear equations is a set of two or more linear equations. The solution to a system is the set of ordered pairs xy that satisfies all equations in the system. There are three types of system based on the number of its solutions, which can be determined by comparing the ratios between the coefficients of x, y, and the constants. You may use this table as your guide in identifying the type of system that is given. For the last stretch, let us see if you really understand our lesson. Have a pen and paper and answer each item within 5 seconds. Are you ready? First question, if a system is inconsistent, then which of the following is true? A, it has no solution. B, it has exactly one solution. Or C, it has infinitely many solutions. An inconsistent system has letter A, no solutions. Next question. Which of the following is not a system of linear equations in two variables? A, x equals y and x equals 2y. B, x squared equals y and y equals x. Or C, x equals 0 and y equals 0. A system of linear equations must have linear equations. Hence, the answer is letter B, since x squared equals y is not a linear equation because the degree is 2. Next, what type of system is given by x minus y equals 0 and x minus y equals 1? A, consistent and independent. B, consistent and dependent. Or C, inconsistent. Upon inspection, A over D is 1. B over E is also 1. But C over F is 0. It means that the given system is inconsistent. Letter C. Last problem. If you have 10 coins composed of 1 peso and 5 peso coins, with a total amount of 38 pesos, how many 1 peso coins do you have? Is it A, 3 coins, B, 4 coins, or C, 5 coins? This is an example of a consistent and independent system given by this mathematical model. The answer is 3 coins. Since 7 5 peso coins will give you 35 pesos plus the 3 1 peso coins, a total of 38 pesos. Like earlier, you can solve this by guessing and checking. But we will have a more comprehensive discussion about this next episode. Did you get them all correctly? I know that you can do it. Keep on polishing your skills and you will be masters of mathematics in no time. If you find the topic difficult, you may consult your self-learning module or visit the DepEd official YouTube channel and review our lessons. next episode, we will illustrate the system of linear equations and its solution visually by graphing two lines on the Cartesian plane. So have your ruler ready with your pens and the graphing paper. With that, this is Teacher Joshua reminding you to practice. Do it with a positive attitude and a smile on your face. Keep on being critical, logical, and responsible. See you again for a math terrific day here at DepEd TV.